Hello everyone, welcome back to the channel. In today's hands-on Kubernetes lecture, we are going to build and test an application using Kubernetes Gateway API, HTTPRoute, and your Next.js, MySQL, Nginx, and K6 through which we will test our applications for the loads. We will start with the front-end form applications. There will be the form will send a data to a Next.js API, and the API will store the data in MySQL, and we will then introduce Kubernetes Gateway API, which will route different traffic to different URLs to different backend services. And we will also configure HTTP routes that will define a rule to route different URLs to different backend services. Finally, we will use K6 to generate load and test the performance of our application through the gateway. By the end of this session, you will understand not only how to use gateway API works, but also know how to use the application traffic flow through gateways and HTTP route, how you can configure different read-write rules and Kubernetes services, the application backend and the database, how the data should be stored under the database services, and how you should configure data services which will save your data or form data to the backend databases. So let's first understand the architecture. We have three important Kubernetes services. The first is the front-end service, which is running on port E3000. This application is basically a Node.js application, which contains our form and the APIs that receives the submitted data. And the second one is the web services we are using right now as an Nginx HTML service, which will run on port 80. And third is the MySQL service, which will basically use to store your form data onto the as a backend database services. So our application basically our application traffic will enter the Kubernetes cluster through the gateway, and that gateway listens on port 80. Then it will you will define a rule that will be your HTTP route rule, then which will examine the URL path and decide where the rest should go. For example, if you define as a hyphen goes to the front-end application, and if you defined as a request to go to the APIs that will be your different Nginx service, then it will be go to your web services, that is your Nginx services on port 80. So this will gives us a single entry point while allowing us to expose multiple applications behind the same gateway. So we have a multiple applications possible here, which where we will route under the HTTP route pool definitions, where we have a multiple services which will be running around. So you can define the routing rule here as well, and you can define a weightage of it as well if you will if you would like to create a multiple if you would like to multiple route rule for which you can define the weightage, so that if you are going to update any services, then you can route your traffic accordingly to that services as well. So let's get an idea of what is your gateway. So gateway is basically um, your entry point, which is uses Nginx gateway class, which means Nginx gateway fabric is responsible for implementing this gateway. So the listener is configured to for HTTP on port 80. An important point to remember is that gateway itself doesn't decide which services should receive API or app or hyphen app that will be basically used to route the traffic. That job belongs to the HTTP route. So it basically decides where the traffic should go and which services on the backend should be it will hit. So the think of the gateway is the entry point, HTTP route as the traffic routing rules. Here you can see that the HTTP rules how we have defined here. So the rules are basically the if you require the traffic is looking for an hyphen API path prefix, then it will redirect your traffic to the front end services on port 3000. If your traffic is requirement is of hyphen, the URL of your path prefix contains your hyphen app, then it will be redirected to your um, that is your Nginx services. And once you will, if you will like to save your data from your services, from your form data, then it will use the path prefix hyphen and it will be redirected to the from API content services. That is basically your if you will look at our codes of your Node.js application where we have configured to saving of our form data onto the MySQL database services. So if we look at here the traffic flow, the user requests that particular app services, then will reaches to the gateway, and then according to the HTTP route tool, it reaches to the front end, or it will be it will be an Nginx service single page, or there will be any form that will be used to store your data. And the backend is a MySQL and return a successful message. Same as if there will be an Nginx app, then it will reach to the gateway, and then through the app URL path, it will reach out to the web services and returns an Nginx page to you. One more thing that we are going to do here is we will test the applications through our K6 load.js test script, in which we will trigger our applications or our form data, and we will look out whether the data has been saved on the backend or not to 100 virtual users. So the data should be the command line will be your K6 run load test.js. Before that, you need to be install K6 on your system. We are basically running that under the locally. So we will give you an overview of how we have done that. So let's get started and start a demo of it. So this is our application where we are locally on localhost, where we have a contact form. Another one is your Next.js applications that is running under the on port 80. So here in this contact form, we will save some data, and we will check that data should be saved under MySQL database. So the data should be like this, and once we will send, then it will save the data successfully. Similarly, on different port, different URLs, we are getting or your path prefix, we are getting Nginx services, and on without any specific path prefix we have given here, then we are having to access contact forms. So these two services are running behind the gateway APIs, and that the routing of this has been defined through your HTTP rules, HTTP route. So let's have an understanding of our codes first. So this is our Next.js applications. Before we move into Kubernetes gateway APIs, let's at first understand the application that what we are deploying here. So this is our web application where we are using uh, a simple web HTML form HTML, where our application is an Next.js application with two important parts. That is a front-end contact form and the backend API that receives the form data and stores into your backend JS. So that is under your API, where we have defined the rule of saving the data on the backend databases. So, and when you will go to the page, we have a HTML page that we have defined here. That is the uh, contact form. There are multiple mm, items. That is your email, name, and message that we are going to save here. So on the click of submit, what action should be triggered? So on the submit trigger, uh, it will trigger a traffic. It will trigger this function that is handle submit, and it will fetch the API contact. And then when it will go to this route table, you will have the data that we have enter under your forms that will be get saved here through this logic. And if there will be any error, if there will be any network error or the database is not accessible, then it will show an whatever the database errors that will be getting, and it will find. And if the data gets saved, then it will show you saved successfully, that we have already give you a demo of it before this code overview. So we are using the how we will create a pool of it. So what the data should be, what will be the host of it. We are taking it as a local host. MySQL user should be user. The password is password. We have taken it as a general. You can take it. You can customize it accordingly as well. You can put it in your environment section. We have put it here, hard coded, but we don't do that in production servers. So here we have an architecture of our applications where the app is continues two part, that is a layout and pages, layout and pages, uh, and the backend logic has been written in the route.js. So basically under your form sections, uh, our file is basically app API contact route.js. The important part is the post function that it will going to trigger and going to save that name, email, and messages to the backend services. Then we will validate the required fields if the name is your email, any validations as well we have defined here. Now the end we executing the MySQL insert statement where we are receiving the data at the backend. And this part is the save successfully after successful messages or database error should be given here. So let's have an overview of the complete application flow. So now let's connect everything together. The user opens the contact form and that is your 127, your local host that we are right now working on our local system. So the user opens the local host, the use browser loads our Next.js front end. The users enters the application with their name, email, and messages and submit that. Then the front end executes this backend logic and saves the data the request basically goes to our post API contact applications. There, the Kubernetes gateway receives the request, the HTTP route that matches where the hyphen API and forwards the request to the front end 3000. Then the Next.js API routes receives the request and the API calls pool.execute and MySQL stores the data. So the complete traffic flow is like that. So the browser hits that applications, and then applications once the flow send, and it will hit the traffic routing. That is your API contact, and through that Kubernetes gateway, it will route it to the API. That is a front end, and if it is a front end, then it will redirect to the port 80,000. And if you are going to save that data, then you will redirect to the API contact and save to the DBGS, and it will then directly save it to the MySQL database and the contact tables that we have created in our uh, uh, app sections. Once we will go into this route section, you will find this. We are going to create it as contact tables where the data should be get saved. Now let's understand how we can Dockerize this application. So for that, we need to understand the application code. Let's put it in under the Docker. So the simplified Docker file looks like this. Here we are using Node.js Slim building image. So basically, it works as a Node.js application. So it basically uses as a Node 26 Slim as a base image. Here we are creating a working directory where we are copying all the application requirements except node modules or that we need to define in the Docker ignore sections that some already built should not be copied under the Docker file so that the image should be get so heavy and it will not be required to be copying everything that is always being built whenever you run the Docker image under the container. So you don't copy that file. So that file should be marked under the Docker ignore, so it will not be getting copied under the images sections when you're going to build an image. So here we are copying everything under this part. Then we will run a build. We are basically doing a multi-stage build. So we are first we will work as a development part. Then final one is as a cloud one, where we are running as a runner and copying all of the things that we have already done under the previous one as a builder sections, and copied that to the production one where we are in next stage. Here we copying all the build file and with this production one. Then we will exposing the applications to 3000 and the entry point for the images should be on npm start uh, for applications to be running under the container whenever we run an image. So this will be the architecture of your flow. That is a flow. That is one is our flow chart of your application, how the traffic should move in different uh, path prefixes, and it will route different services. It will access different services, and through that different service, if there is any connected backend services, then it will be used to do that as well. And here we are using front-end applications where the data is a form table, and we are through APIs we are accessing the same applications for saving the data into the backend database services. And here we are only using hyphen app path prefix for simply accessing any other services that we have under the port name. That is an Nginx service. If there will be any e-commerce services where we have multiple options, that is a login section that is built under the Java, or if there will be any card services which is written under the Next.js. So you can define that one and you can integrate that all services under this gateway APIs. So it will basically use to receive traffic and uh, route that one to the according to the requirement or the traffic rules that the user wants to access that one. And accordingly, you can define your HPA service horizontal pods of the scaling so that that specific pod should be get scaled under the heavy loads or requirements. So other services should not be get hampered on the remains available for the accessible users or those users who are looking for it. Now that we will going to understand what are the now we will understand our Next.js application. Let's see how we deployed it into our Kubernetes. We are going to create two Kubernetes resources, that is a deployment and services. The deployment runs on Next.js applications where we are running under the deployment runs our Next.js application inside a house where the service provides a stable network endpoints to access the pod. So here we have a simple deployment files that we are using that image. We have already created an image and push it to the Docker repositories, and we are using this image for uh, for accessing that image. And we have some defined some resources So we have defined some request and limits as well because we are going to use HPA. For that, we need to specifically define resource limit for that particular pod. So if the pod's limits if the pod limit's not up to the mark, then it will start scaling, and CPU utilization according to CPU utilization start scaling as well. So these are the basically. So what are the kind of this deployments are is so so what kind of uh, this deployment file is this test Kubernetes that we want to create a deployment, and instead of manually creating pod, we will tell Kubernetes run my application and make sure the required number of replicas are always available. So we have already defined the number of replicas. Next is the deployment name, number of replicas, selectors, which basically used to tell the deployment which pods belong to it. And whenever you are creating services, then you will definitely have to have a reference name that you can define here. So once you will go down here, you can see that we are using the selectors frontend for this deployment that will match this label. And it will open on port 3000 since my application is running on port 3000. So we have already defined as a NodePort services, which will have a protocol of TCP, and the NodePort has been already been defined. You can, if it will not be defined, it will get automatically gets created. Now, uh, under this for this image needs some specific environment variables. So we have already defined this one. Since the data has been already been created through our MySQL secrets under the secret of YAML. So we have already created a MySQL secrets. So this secret should store this data, that is a user data, password, and databases. And whenever the container should run, it will use that key reference for fetching that value of it through the secrets. So through the MySQL user key values will fetch the data of your required values. So we have a MySQL user defined, MySQL's password, and secret key reference has been given as a MySQL database. So the secret key, this one is a secret name, and this is a reference key value, key field. So, and the value related with this key should be guessed and being used under this image whenever it will run under the container. Now, why we are using NodePort? So basically, this is an important question. In our final architecture, the gateway will communicate with the Kubernetes services. The gateway doesn't need us to expose the application publicly through the NodePort. So for a production stand gateway API architecture, we can actually use cluster API instead of NodePort. But basically, we are running it and as an application. So we are running it as a NodePort. So you can do that as well. You can convert it to the cluster IP as well. If a load balancer based application, then it will be better to use it as a cluster IP. We can use NodePort for learning for or direct testing, but the gateway API architecture can use a cluster IP services. So now let's go to the backend services. So under the backend services, we know that what is the kind of this. So it's a deployment file. We are we are not creating any replicas of it. So the SQL image we are using that is basically used to create a database of MySQL. We are also providing the same as the whatever the data environment variables that will be required. So the MySQL secrets will going to define MySQL secret, it's been defined here. So we have already created this password. So we are using the same thing in our front end, in our backend applications, where we are creating environment variables with that MySQL secret, which will fetch the data MySQL password and be used under the MySQL when you will run it locally. So let's see if you have a running applications. So let's see, I will give you an overview of how it works. So I have a running applications. So once you will, so here we need a password when you will run a MySQL locally to access the whether the data has been getting saved or not. So it will show you here. You can see that through this command to be executed under the shell script, and you will run this pod MySQL. You need to have a user profile and host should be defined here. So that is basically defined there. Here we are defining MySQL root password, MySQL user, and the host name, what the database we are going to use, what password should be used, what will be the port name, and we are also attaching my some volume to it so that the data should not be get deleted. So it will be retained until unless we have not deleted the cluster. So for that we have already created. We are creating a PV persistent volume. So since we are done doing it in locally, so we have keep it as a host path as entry data in MySQL. The storage we have defined here is 6GI. Storage class name is standard. Persistent volume reclaim policy is retained. It will not be get deleted until unless we are not going to delete this persistent volume. So, and how we will create that, how we can access the specific amount of our volume. So for that, we will be going to use this persistent volume claim, so which it will claims how we will going to access that persistent volume. So it will be write once. So it will only read and write only once. Read write multiple. You can also do that. So and simultaneously read write both should work. But in here you will read only and write once. Once means at a time only one application. One access mode should be only open. So what are the resource request? How much since under the PV we are giving 6GI, but out of it we are only using 5GI request only. We will trigger only the request of 5GI, and the volume name should be MySQL PV. So here under this backend sections we are using this uh, persistent volume claim. So this volume should be on space on this volume. We are specifically on space particular in a particular folder like structure. We are saving that MySQL database that we have already saved some data here. So if you will go and show you, select. So, so So under the load test, you can see here we have saved some data and triggered an application. So it was saving some data. So you can see the multiple data here due to that. So multiple YAML files we are using here right now, customization.yml, so that it will trigger and will all it will you will not have to deploy all the YAML files one by one. It will automatically run all those one in a faster way. So once you will going to write apply, sorry, hyphen K and hyphen, since it is not in the deployment. So first comes out of it. Now I will once run this one. You will find that everything is right now. We have not already deployed that, so it is not showing any changed. Since once you will start it uh, on a fresh, you will find that it will find that service frontend created, service MySQL created like that. And we have also defined some HPA as well, horizontal pod scaling for front end. So we have defined as minimum replicas of one and maximum of up to five. If the CPU usage goes beyond 20, and how much the time should be required to be get stable once the traffic should be get, and the CPU utilization gets below the 20% of it. So once everything should be get deployed, you will find that it's whether the application is running or not. So all the services are basically running here. You can see here, except this front-end gateway. So let's understand the gateway as well. So before deploying a gateway, you need to have a first need to deploy a gateway services gateway. So this one is the gateway structure of it. We are using gateway class name, that is your Nginx. So let's whenever you are going to deploy a uh, gateway, you need to have a gateway class name. So for that, you need to first deploy your Nginx um, CRD first before deploying. So if you will have an open one, let's give you an overview of it. Since we are deploying, if you will have a CRD, I will give you an overview of it. So for gateway CRD deployment, we have used this command. The gateway keeps it in customized gateway Nginx gateway fabric, and this you will download all the CRDs. And after that, you need to install the Nginx gateway. That is basically your helm install Nginx OCI gateway fabric. Through the Nginx portal, you can find that one. How you can deploy, uh, how you can deploy Nginx gateway services under the namespace of Nginx gateway. So here you can see that I have used Headless hyphen and Nginx gateway. So it is showing me the under the Nginx gateway that uh, Nginx is already been deployed. So here you can find that this Nginx gateway is running here with this front end gateway. So basically this is your gateway. So if we go into safety here, get gateway. Uh, Here we are getting two application services. That is basically the HTTP route behavior. That is basically here. So what exactly this one? I'm going to explain you. So this is the parent reference. That is your basically your gateways gateway name that we have already defined. And this is one is your HTTP route, which is basically using your front end gateway route. We have defined some name, and that is the kind of it is your HTTP route. Metadata is your front end route, and parent reference is a gateway name that we have already defined for the under the gateway about YAML. The rules has been defined here. The matches that is R prefix, how the how the traffic should route to the different web services. So we are basically rewrite tool. We are using URL rewrite, basically means when we will trigger when we will the user write an hyphen app, it will be direct to the replace the prefixes to the only hyphen and will reach us to the web services that is on the backend. So we are basically using the web services name for the reference on the backend. Similarly, if you'd like to have an access of front-end services, we will use it for the hyphen APIs, and it will redirect the traffic to the front-end API, that is your 3000 on product, which is running on port 3000. Similarly, if you will have to only access the uh, front end, then we will only use that path prefix of hyphen, and then it will be used to the front-end services. It is basically the form services that when you're going to submit that form, so that's for that you need to have this extra rule should be defined here, so that it will going to connect with your database services. So where we if we are right now we are using minikube cluster, so that for that we need to start running your minikube tunnel as well. Otherwise, it will not create a gateway services or not provide IPs that will be required for these services to be running. If you are running this application on EKS cluster, you will not be have these issues, since if we're going to have if you will find that this service is the front-end gateway service is a load balancer type. So it is providing the external IPs, which is basically mostly required for if you are running it or checking it under the under your locally or Minikube services. So Minikube color cluster. So it needs to be running as a load balancer, so that it will route your traffic in between your different services in the backend. So this is the Nginx gateway services that is a class that we need to download before running your gateway, since we are using Nginx gateway class. So for that you need to download API services, different CRDs, and after that you need to install through Helm the gateway fabric under the namespace of Nginx gateway, and run the following command, that is a helm command. So this is one. So we have already deployed and running an application used for the contact form, and this is the we have already shown you the how you can save the data of this one. And this is the next application that is running your welcome to Nginx services. So both these services are running here. So you can also run your Minikube dashboard as well. So here in this dashboard, so you can see here the multiple deployments are running here, and what pods, if there will be any replica sets, so that is also being shown here. So you can set we have not specifically defined any jobs here, cron jobs there. So here the number what are the pods that is basically running here. Python and web apps are running here. One web front end application is running here, which is using this image name. We have an app gateway and Nginx app, that is your load balancer type, that what image that is being used here, what are the labels has been defined, under the which node we are running it, we are using locally, so that we are using Minikube. What is the status of it, how much restarts has been done, if there will be any restart, so if the pods resources gets consumed, then it gets restarted as a new one, or there will be an error, or so it will get restarts. So any specific CPU usage is not getting monitored there. So and the time durations of how much time it has been gets created. So if we go to the Ingress, so we are not using any Ingress. We are using right now the gateway APIs, since the Ingress has been deprecated now. So once we fill the persistence volume, we can check the what persistent volume has been used and where it is attached to this persistent volume, and the status is bound. If it will be not attached, then it will be shown not attached. What are the capacity of your persistent volume claim and how you can access that? What are the storage class? So all has been defined here. What are the different secrets has been? Then you can also track it here. What are the any storage class? So we are for persistent volume, we are using standard storage class. We have not defined any cluster rule bindings, network policies. Only the persistent volume has been defined here, so you can check it out here. It's already been created. So these things has been under the MySQL dashboard. You can check it out. So this is one was so let's get have an overview of how we can test and test these applications. So K6 load. Before that, you need to install K6 through Grafana through different different options that is available here. Either one, two, or in Windows, you need to install it first, and through the command prompt, you can run that script for testing your applications. So here you can see that we are running an K6 run load.js commands that we have already given you an overview of what is your load.js and how it looks around. How we are creating an JS command. So through that, this is the execution results that we have created. So what are how many attempts they have done? How many of them how percentage of it that gets executed and succeeded, and how much of it has been gets failed. So the form page status has always been 200. The contact pages where 99% was correct, except one where the data has been failed. And Nginx app status, that is the Nginx app services that we are running on OTT. It is also showing 200. So we are not having any issues there. So we have done this load test with 100 virtual users. So it triggers only 46 100 HTTP request and 0 uninterrupted iterations has been found. So all the 100 virtual users has been the load test for it has been gets executed. So you can configure that load.js part as well, and you can configure according to a requirement as well. So for today, this one was a interactive overview of how you can develop and create an applications on Kubernetes and deploy it there. Similarly, you can follow the same structure in EKS cluster, where we need to create a load balancers and mini tunnel as well for the creating an IP addresses. There you can easily access it under the cluster level. So this is the basic architecture. You can do the same on your EKS or ECS as well. So thanks for watching. We will get back to you with multiple other services and multiple other knowledgeable interactive sessions. Thanks for watching. Please like and subscribe this channel. Bye.